my name is Aimee Campbell and I've finished putting together my project for assignment 2. So this is the Arduino board. I've got the system unplugged right now. So what I'm going to do first of all is plug in the 9-volt battery power supply for the Arduino processor, and then I'll hold it steady, allow it to reach, just allow it to set to 0 at that position I'm holding it. And then when 10 seconds elapses, the system will rotate 180 degrees and then it will maintain its heading there. So I'm just going to go ahead and plug in the unit. So it's running now. I'm just going to hold it steady as I zero the system. So it's quite important when you start it that you hold it as still as possible. If you destabilize it too much, it tends to struggle to get back into that stable state before it does its turn. So it's doing its turn now, 180 degrees. And I found that that small overshoot that you observed, it's maybe 5 or 10 degrees of overshoot, was an optimal choice for this design to ensure that it has a responsive system. So I found by increasing its rate of turning, it would help get it to its set point quicker, and that small overshoot is then very quickly removed from the system and it brings it back into a stable position. So right now you can see that it's running quite stably. There's no oscillation observable. It's holding itself extremely steady, and I found that this was due to the calibration choices that we made for the constant offset for the gyro. So I found that when you run a calibration for this sort of application where it's only running for a small period of time, that it was better to take a small sample set rather than a large sample set, as the large sample set works well over a long period of time, but initially it's actually not that accurate because the gyro isn't very warm yet and it hasn't been running for, say 5 or more minutes. So I chose these offsets based on the amount of time I expected the system to run. So what I'm going to go ahead and do now is I'm just going to rotate the ruler around and just show that the sign remains steady even if the string is disturbed. So this demonstrates that it's not affected by external forces. So you can rotate the string, it can be disturbed by wind or by, say, the blimp moving around. So this is like an indication of how the blimp would be rotating around, and the sign continues to face towards the audience. So you can see the sign slightly was off and now it's bringing itself back around to 0. So it's quite a stable system now and I'm quite happy with its performance. If I was going to leave it running for longer, I think that I would need to look at those calibrations and how we're going to integrate them on a long system runtime. But for the moment, for these short periods, it works quite well. Thank you.